Hello class, I hope you're having a wonderful day. Today I would like to take a look at the theater students practice problem from chapter 5. Okay, let's go ahead and get started. Two theater students stand on a platform and use ropes to pull up a box containing stage props, which have a total mass of 27.75 kilograms. The students stand on opposite sides of the stage and pull at the angles indicated. So right here I've drawn a picture and I've labeled this. Student 1 is applying a force, and I've used a subscript of 1 here. So force 1 is equal to 190 newtons at 50 degrees with respect to the x-axis in the positive x direction. Force 2 is 180 newtons, and it is applied at 55 degrees with respect to the x-axis in the negative x direction. Now, the first thing we are going to need to do is calculate the weight force of the crate. So we know that weight force is identified by F sub g, and this is the product of the object's mass and the acceleration due to gravity. The mass in this case is 27.75 kilograms, and we're multiplying this by the acceleration due to gravity, negative 9.8 meters per second squared. So let's go ahead and take out your calculator. So 27.75 times negative 9.8, we get negative 271.95 newtons. We know that a kilogram meter per second squared is equal to a newton. So this is the weight force. Now what we need to do is draw a free body diagram of our system of forces. So remember, whenever we draw a free body diagram, our arrowheads always point away from the system. Okay? So my system is the crate here. We have a weight force identified by F sub g. Right here, the direction is indicated by the negative sign, but in our free body diagram, we have our vector arrow pointing down. You see our arrowhead pointing in a negative y direction, and since that is indicating our direction, we do not need the negative sign. So we're just going to label it 271.95 newtons. Now, we need to take a look at force 1. Force 1 is 190 newtons, and I will indicate the direction here, 50 degrees. The next is 180 newtons, force 2. At 55 degrees, okay? So what we want to do is use a table that shows the x and y component for each vector, and then we are going to sum the x and y components together. This will give us the x and y component for our resultant vector. So we're going to label our table vector x component and y component. Okay, let's go ahead and put a double bottom border here to separate our column headings from the data in our table. So vector 1 is going to be force 1, vector 2 is force 2, and vector 3 is going to be the weight force of the crate. Okay? And we also need sigma, the sum of. This is going to be our final row because we are going to sum all of our components. Okay, so there we have our table there. So for force 1, we are going to use vector resolution to break our vector down into its x and its y component. So right here, we know that our vector has a force in the x direction and a force in the y direction. Okay? So, what we're going to do to calculate the x component, we have F sub x is equal to force 1 times cosine of 50 degrees. Okay? And this is going to be a positive value on force 1. So positive 190 newtons times cosine of 50 degrees. And this is positive because our x component of this force is headed in a positive x direction. So on your calculator, make sure that you're in degree mode. So 190 cosine 50 degrees. This is equal to a positive 122.13 newtons. Okay? For our y component, we're going to use sine. So F sub y is equal to our force 1 times sine of 50 degrees. Okay? Force 1 is going to be positive because you can see that our vector force 1, the y component is headed in a positive y direction. And we can also make a prediction, since our angle theta here is greater than 45 degrees, we're at 50 degrees, that our y component will be greater than the x component. So let's see if we're right here. So force 1 is 190 newtons, and that's positive, times sine 50 degrees. This is 145.5 newtons. Excellent. Yes, so our y component is slightly greater than our x component. Okay, so we're finished with force 1. Let's move over here to force 2. Right here. So we have an x component and a y component. My x component I will label as F sub x, and my y component F sub y. For my x component, F sub x is equal to force 2 times cosine of the angle theta. Okay? Well, before we write anything down, we have to ask ourselves, is force 2 in the x direction positive or negative? Well, let's take a look at our vector arrow. So, force 2 acting at 55 degrees. In quadrant 2, we're going upper left-hand corner. Let's look at the arrowhead on our x component. So we're pointing in a negative x direction. So for force 2, this value has to be negative. So negative 180 newtons times cosine 55 degrees. I get negative 103.2. Okay? Now let's take a look at the y component. So for my y component, if we take a look at the vector, we see that this vector is pointing in a positive y direction. So F sub y is equal to force 2 times sine of the angle theta. I have a positive 180 newtons times sine of 55 degrees. And I get 147.4. Okay, so we're done with force 2. Now let's take a look at the weight force due to gravity for the crate. Okay, so right here we have the weight force at 271.95 newtons. And if we look at this vector, we know we have a pure y component vector. There's no x component. Right here, x component is 0. Y component is 271.95 newtons. I'm sorry, negative 271.95 newtons. Now, we need to go ahead and sum each column. And when we get the answers down here, these are going to be the x and y components for our resultant vector. So, for x, 122.13 minus 103.2, I get a positive 18.93 newtons. in the y direction, I have 145.5 plus 147.4 minus 271.95. And I get a positive 20.95 newtons. Okay? All right, so we need to draw a new right triangle based on the sum of my x and y components. So I'm going to draw a point. This is going to represent my origin. So in the x direction, we have, I'm going to label this as my x component of my resultant vector. So f sub x sub r. This is 18.93 newtons. My y component, and we're using the head to tail method, so I'm going to place the tail of my y component vector on the head of my x component vector, and this is f sub y sub r. So the y component of my resultant vector is 20.95 newtons. And remember that the resultant vector is going to begin on the tail of the first vector and end on the head of the last vector. So what we have here is our resultant. And I'm going to go ahead and use vector notation with my vector arrow above right there. And right now we can calculate our resultant vector by using the Pythagorean theorem. So our resultant vector squared is equal to the x component squared plus my y component squared. My x component is 18.93 newtons plus y component 20.95 newtons, and we have to square those values. So on the right hand side of the equal sign, I'm going to have $797.25 newtons squared. What we're going to do is take the square root of the left-hand side and the right-hand side. On the left-hand side of the equal sign, our square root and our squared are going to cancel. On the right-hand side, not only are we taking the square root of the numerical value, we are also taking the square root of the unit value. So our resultant magnitude is equal to 28.24 newtons, okay? And so this is the net force in my system of forces. So for part A, we're looking for net force applied to the crate. This is 28.24 newtons. Okay. And now part B wants us to calculate the angle or the direction. And what we're going to do is we are going to calculate the reference angle here. So what I have is theta equals arctangent of my y component divided by my x component. My y component is 20.95 newtons. My x component 18.93 newtons. You can see that the units of newtons go ahead and cancel out. And just by looking, just visually, we can tell that angle theta is going to be greater than 45 degrees, just the way that our triangle has been drawn. I tried to keep it, within appropriate scale here, okay? It's proportional. And then right here inside the parentheses, when our ratio is greater than 1, angle theta will be greater than 45 degrees. So arctangent 20.95 divided by 18.93, we get 47.9 degrees. Okay? So angle theta, 47.9 degrees. And if we were using the full angle method, that would be all. If we're using the component method, we can describe this as north of east, or you can say quadrant 1 even, okay? Because we're using a reference angle. Now, on part C, it wants us to calculate the acceleration of the crate. Now, according to Newton's second law of motion, we know that the acceleration of an object is directly proportional to the net force applied to the object and inversely proportional to the object's mass. So, acceleration is going to equal our net force. We're going to use our calculated value, which is 28.24 newtons. We're going to divide by the object's mass, which was given to you here, 27.75 kilograms. Let's talk about the numerical value first. I get 1.018. Now, taking a look at our units, what I have is newtons divided by kilograms. Let's go ahead and break up a newton. We know that a newton is a kilogram meter per second squared, and then we're dividing by units of kilograms, which can be written as kilogram over 1. When we divide fractions, it's like multiplying by the inverse of the denominator. So what we have here is kilogram meter per second squared times 1 over kilogram. And you see that we have a kilogram in the numerator and a kilogram in the denominator. They cancel, leaving us with units of meters per second squared. So our answer for part C for acceleration is 1.018 meters per second squared, and our acceleration will be in the same direction as the net force. Okay, I hope me working through this problem has helped. If you have any questions, feel free to give me a call or send me an email. I would love to help you out. I hope you have a great day.